so in this session, we will start with a topic called log or logarithm. Okay. To understand log, we need to understand indices, index, power. Okay. So for example, if I have 2 raised to the power 5, we know the value of this is equal to 32. So 2 to the power 5 value is equal to 32. Now, what is the meaning of log? In short, this logarithm is called logs. Alright, how do we express it? So log is a function which tells us that a given number is what power of another given number. So in this case, 32 is which power of 2. So if I write it like this, 32 is which power of 2. For this question, the answer is 5. Alright. Now, for this whole process, there is one single expression. So this statement can also be written in the form of log, and it is like this. Log of 32 to the base 2. So this statement is written here. So log of 32 to the base 2 is equal to 5. So we say because 32 is 2 raised to the power 5, we say log of 32 to the base 2 is equal to 5. So this expression defines log. Alright. So how is it read? It is read as log of 32 to the base 2. Log of 32 to the base 2 is equal to 5. Alright. Now let's define it theoretically. So theoretically we can say that if we have a number a to the power x is equal to n, then log of n to the base a is equal to x. So n is the number, a is the base, x is the power. So if this is true, if a raised to the power x is equal to n, then log of n to the base a has to be equal to x. And if this is true, log of n to the base a is equal to x, then n is equal to a raised to the power x. Let's take some examples. If I have log of 81 to the base 3, how much is it equal to? It's a very simple thing. You think about the powers of 3. Now, what are the powers of 3? 3 raised to the power 1 is equal to 3. 3 raised to the power 2 is equal to 9. 3 raised to the power 3 is equal to 27. 3 raised to the power 4 is equal to 81. Right? So 81 is 3 to the power 4. So we say log of 81 to the base 3 is equal to 4. This is how logs are defined. Okay, we'll take some more example to understand this. Now let's suppose we have log of 8 to the base 2 is equal to. So what you have to think is, what power of 2 is equal to 8? What power of 2 is equal to 8? So 8 is 2 to the power 3. So log of 8 to the base 2 is 3. Let's say log of 25 to the base 5. What do you have to think? 25 is what power of 5? So 25 is 5 square. So log of 25 to the base 5 is 2. Let's take some more examples. Log of 27 to the base 3. How much is it? So think about the powers of 3. 3 to the power 3 is 27. So log of 27 to the base 3 is equal to 3. Alright. Let's take some more examples. If I say log of 625 to the base 25. Now, so 625, we know it is 25 square. Hence, it is equal to 2. But if it was log of 625 to the base 5. So which power of 5 is 625? It is 5 raised to the power 4. So log of 625 to the base 5 is equal to 4. Let's take log of 81 to the base 9. So 9 square, we know it is 81. 9 to the power 2 is 81. So log of 81 to the base 9 is equal to 2. Suppose we have log of 128 to the base 2 is equal to. So if you read the powers of 2, it is 2, 4, 8, 16, 32, 64 and then 128. So 128 is the 7th power of 2. So 1, 2, 3, 4, 5, 6, 7. 2 to the power 7 is equal to 128. So log of 128 to the base 2 has to be 7. Alright. Now let's take some different examples. Now, what about log of 3 to the base 9? So what power of 9 is 3? Okay, we know that 3 square is equal to 9. That means 3 is equal to square root of 9. Now square root in terms of power, it is written as power half. So it is 9 to the power half. So we say 9 to the power 1 by 2 is equal to 3. So log of 3 to the base 9 is equal to half. What do you have to think? 3 is which power of 9? Right? 9 to the power what is equal to 3? So that is equal to 1 by 2. So answer of this is 1 by 2. Let's take another one. If I have log of 2 to the base 8. Now we know that 2 to the power 3 is equal to 8. That means 2 is equal to cube root of 8, and cube root of 8 in terms of power is written as 8 to the power 1 by 3. So log of 2 to the base 8 will be equal to 1 by 3. Alright. So there can be some fraction powers also. Now there can be some negative powers also. Suppose we have log of 1 by 2 to the base 2. How much is this? Now how do we do this? Let's see. We know 2 to the power 1 is equal to 2. We know 2 to the power minus 1 is equal to 1 by 2. Alright. And we have to find log of 1 by 2 to the base 2. Now 1 by 2 to the base 2, that will be equal to minus 1. So the power is minus 1. Let's take another one. Suppose we have log of 1 by 9 to the base 9. So what power of this base 9 is equal to 1 by 9? So we know it is, we can write this as, this 1 by 9 is written as 9 to the power minus 1 to the base 9. So 9 to the power minus 1, that is equal to 9. So it is minus 1. Let's take. So now if you have understood the basic meaning of log, let's understand the rules of log. Now let's try to learn the rules of log. The first rule, rule 1, it is also called the rule of power. Let's see what it means. The rule says that if I have something like log of a to the power x to the base b, then this power x comes outside. Everything remains as it is, just this power x comes outside. So we can write this as x log a to the base b. That's it. So x log a to the base b. Similarly, if there is a base which has some power, so let's say log of a to the base b to the power y. So what will happen? Even this power y, even if it is the power of base, it can come outside. But when it comes outside, it comes in denominator. So this can be written as 1 by y log a to the base b. Now suppose both the number as well as the base have some power. So we can write them as, let's say, log of a to the power x to the base b to the power y. So here the number itself is a to the power x and the base itself is b to the power y. So both the powers x and y will come outside. Just remember, the power in the number will come in numerator, power in the base will come in denominator. So this becomes x by y log a to the base b. So this is the first rule. Let's take some examples. Let's some more complicated examples. If I have log 1 by 9 to the base 3, we have done this earlier also? No, we haven't done this earlier. So let's take this one. Log of 1 by 9 to the base 3. How can we do it? Let's try to see that this 9 is 3 square. So we can write it as log 1 by 3 square to the base 3. Now something in denominator, when it goes in numerator, the power becomes negative. So we can say it is log of 3 to the power minus 2 to the base 3. Now whatever is the power here is minus 2. So minus 2 will come outside. So it is minus 2 log of 3 to the base 3. Now 3 is what power of 3? Now any number for itself, it is power 1. So it is log 3 to the base 3 is 1. So we can say it is minus 2 into 1. The final answer will be minus 2. Alright. Now let's take the next example. Suppose we have log of 8 to the base 4. Now what is this equal to? Now here 8 is not the direct power of 4. But both 8 and 4 are powers of 2. So we can say it is log of 8 can be written as 2 to the power 3. 4 can be written as 2 square. So what will happen? This power 3, and this power 2 will come outside. The numbers that I have put as star mark will come outside. So this 3 comes outside in numerator because it is in number, and this 2, because it is in base, will come outside in denominator. So we will have 3 by 2 log 2 to the base 2. Now what is log 2 to the base 2? Any number to itself, it is the power 1. So log 2 to the base 2 is 1. So this whole thing is 1. So final answer is just 3 by 2. Let's take another one. Suppose I have log of 125 to the base 625. Now we know that 125 is not a direct power of 625, but both of them are powers of 5. Now 125 is 5 cubed. 625 is 5 to the power 4. So from here this 3 will come outside, this 4 will come outside, and it will become 3 by 4 log 5 to the base 5. Now you see, log 5 to the base 5 is 1, so the final answer is 3 by 4. So this is how rule of power can be applied in complicated situations. Even in this case, where we have, let's say, log of 2 to the base 8. Now this can be written as log of 2 to the base 8 can be written as 2 cubed. So here this base has a power 3. So this 3 will come outside and will come in denominator. So 1 by 3. There is no power in the number. So it will be log of 2 to the base 2. Now log of 2 to the base 2 is 1. So final answer will be 1 by 3. Alright, let's take another one. If I have log of 1 by 3 to the base 1 by 9. Now see, 1 by 3 can be written as 3 to the power minus 1. And this 1 by 9. 9 is 3 square. So 1 by 3 square. Hence it is 3 to the power minus 2. So what will happen? This minus 1 will come out. Minus 2 will come out in denominator. And inside we have log of 3 to the base 3. Now log of 3 to the base 3 is 1. Minus and minus cancelled. So we will have 1 by 2 as the final answer. But this rule or this process can be applied only when both the number and the base are powers of the same base or powers of the same number. Only in those cases the simplification can happen. Now if the base and the number are not powers of the same base, then what do we do? Let's take an example. So if I have log of 9 to the base 16 and the question says simplify, then let's see what we do is we can say log of 9 can be written as 3 square. 16 is a power of 2. That can be taken as 2 raised to the power 4. So this 2 and this 4 will come out. So it will become 2 by 4, and inside we have log 3 to the base 2. Now we cannot do any simplification for log 3 to the base 2. So leave it as it is. But 2 by 4 can be simplified as 1 by 2. So the final answer will be 1 by 2 log 3 to the base 2. That's it. This is the maximum simplification that you can do in this particular situation. Now let's move on to the next rule, rule 2. It is rule of multiplication or division also. How does this work? Let's see. Suppose we have log of x into y to the base b. Now we can separate them. If we separate them, what happens? We have log of x to the base b plus log of y to the base b. So understand, the base remains same. The numbers split, right? Because here whenever there is a multiplication, we get a plus sign, and log is applied to both the numbers. So log of x to the base b, log of y to the base b, and they get added. So whenever there is a multiplication between the numbers, there is an addition between the logs of those numbers. All right. So if it is, let's say, log of x, y, z to the base b, so we can say it is log of x to the base b plus log of y to the base b plus log of z to the base b. This is how it goes. All right. Let's take the example of division one. Suppose we have log of x divided by y to the base b. Again, they can be separated. Again, there will be two logs. It's just that when there is a multiplication, we have a plus sign in between logs. When there is a division between numbers, there will be a minus sign between logs. So this will become log of x to the base b minus log of y to the base b. Alright. Let's take a mixed example. If I have log xy divided by z to the base b. How would you open it? If you see x into y divided by z, so wherever there is a multiplication, they will be added, and the number which comes in division will be subtracted in the log. So it will become log of x to the base b plus log of y to the base b minus log of z to the base b. Let's take some questions on them. Suppose there is a question that says simplify. One important thing, this rule that we just learned, I'll write it again, log of xy to the base b is equal to log of x to the base b plus log of y to the base b. It can be applied both ways. Alright, so if there is an addition of logs given, if the bases are same, you can multiply the numbers. Similarly, log of x upon y to the base b is equal to log of x to the base b minus log of y to the base b. This also is applicable both ways. Just that remember, when you go from this right hand side to the left hand side, the base has to be the same. Then only you can do that process. So let's take an example. Suppose we have simplified log of 25 to the base 10 plus log of 40 to the base 10. Right? Now, what do we see here? We see that there are two logs and the bases are same and there is a plus sign. So what we can do is, we can take one single log, and because there is a plus sign, the numbers inside can get multiplied. So it becomes 25 into 40. Now 25 into 40 is 1000. So log of 1000 to the base 10. Now see, 1000 is 10 to the power 3. So it becomes log of 10 to the power 3 to the base 10. Right? So this 3 comes outside. So we have 3 log 10 to the base 10, which is 1. So the final answer of this question would be 3. Suppose we have a question which says log of 25 to the base 10 plus log of 24 to the base 10 minus log of 4 to the base 10. Find value of this. And it is given that log 2 to the base 10 is 0.301 and log 3 to the base 10 is 0.477. So this data is given and you have to find the answer of the value of this expression. Now what do we do? What we can do here is, one is that we can separate all of them, or we can calculate each one of them separately and then add or subtract. Or what we can do is we can combine all of them like this. See, there is a plus sign here, so these two numbers will get multiplied. There is a minus sign here, so this number will be divided. So we will have log of 25 into 24 divided by 4 to the base 10. Now 4 cancels 24 6 times. So we have 25 into 6, so that becomes log of 150 to the base 10. Now 150 can be written as log of 150 can be written as 300 by 2. So it is log of 3 into 100 divided by 2 to the base 10. Now if we separate them, 3 into 100 divided by 2. So we will have log 3 to the base 10 plus log 100 to the base 10 minus log 2 to the base 10. This is what we are going to get. Now this becomes very easy because log 3 to the base 10, the value is already given. Remember, you will never have to memorize the value of log. You will never have to calculate the value of log from your side. The data required would be given. So that also is a hint. If something is given, you have to use it. So it becomes 0.477 plus. Now we know that 100 is 10 square. So it becomes 2. Log 100 to the base 10 is 2. Minus log 2 to the base 10 is given 0.301. So 0.477 minus 0.301 will become, the whole thing, if you add, subtract, it will become 2.176. Alright. So 7 minus 1, 6, 7 minus 0 is 7, 4 minus 3 is 1. So final answer of this question is 2.176. So this is the second rule of log. Suppose we use the same data and it says log 2. Suppose if it is given that log 2 to the base 10 is 0.301, log 3 to the base 10 is 0.477. And the question says find the value of log 576 to the base 10. How do we do this? Let's see. Now we know that 576 is square of 24. Now if you remember the square, well and good. If you don't, then you can factorize. Let's say 576. If you factorize, if you remember the method of factorization, divide by 2, it will give you 288. Then again divide by 2, it will give you 144. Now at the same time, if you remember the table of 4, you could have directly taken out 4 or divided by 4 to get 144. Now 144 is 12 square. So 576 effectively becomes 2 into 2 into 12 square, which is 2 square into 12 square, which is 24 square. 24 itself is 8 into 3. So it is 2 cube into 3 whole square. Right? So this is the factorization of 576. So if I write it here, let's see what happens. Let's write it as log of 24 square to the base 10. I have just explained factorization as an extra thing. In this question, first of all, write 576 as 24 square. What will happen is 2, because it is a power, it will come outside. So it becomes 2 log 24 to the base 10. Right? Now this 24 is 2 cube into 3. 24 is 8 into 3, which is eventually 2 cube into 3. So what we can do here is, we can write it as 2 log 2 cube into 3 to the base 10. So this 2 is completely outside, and inside we have these things. Now this 2 is completely outside. Inside we have log of, now you see this is 2 cube into 3. So whenever there is a multiplication, logs can be separated with a plus sign. So log 2 cube to the base 10 plus log 3 to the base 10. Alright. So we have 2 into, now from here, only from this 3 comes outside. So it is 3 into log 2 to the base 10 plus log 3 to the base 10. So now whatever values are given, you can use them here. So I'll take here, I'll write it here. So this expression comes here, and we have this 2 is completely outside, as you can see. So it is 2 into this 3 that is already there into log 2 to the base 10 is given here, that is 0.301, and then this plus sign, so plus, and then log 3 to the base 10. Now log 3 to the base 10 is here, so it is 0.477. So you have to add them carefully. Right? So it is 2 into, now 3 into 0.301 is equal to 0.903 plus 0.477. If you add, you will get 2 into 3 plus 7 is 10, 0 plus 1 plus 7 is 8, 9 plus 4 is 13, so it is 1.38. So final answer is 2 into 1.38, which is equal to 2.76. So the final answer of the question is 2.76. So log of 576 to the base 10 is 2.76. These values must be given. Alright. Now we'll move on to the next rule. It's a very important rule, that is rule 3. And here this is called rule of multiplication of logs. Earlier what we did was multiplication of numbers inside the log. Here we are talking about multiplication of log. Now how does it work? Let's see. Suppose I'll give an example. Can you say anything about log of a to the base b into log of c to the base d? No, there is no rule for this. I'm giving you all different possible situations, then we'll go back to the rule. First this one, there is no rule. Can we say anything about log a to the base b into log c to the base b? Now here there was no relation between the numbers and the bases. Here there are two logs, the bases are same. Can we say anything about them? No. Be very careful. There is a very specific situation in which the logs multiplication is possible. Right? Let's take another example. If I have log a to the base b into log a to the base c. So here the bases were same, but we don't have any rule. Here the numbers are same. Do we have anything? No. Here also there is no rule. There is only one situation which is like this. Log of a to the base b into log of b to the base c. Now this is a very peculiar specific situation. First note it down clearly. There must be two logs multiplied. Base of one of the logs should be the number in the other log. You remember, this is the position of number. This is the position of base. This is the position of number. This is the position of base. So base of one log should be the number in another log. Then only the multiplication is possible. And what is the outcome? The outcome is, if this is true, then the outcome is only one log, right? And one log, and in which the numbers will be other than the common number. So b was common, so b gets eliminated, and the final answer will be log of this number to this base. So it is log of a to the base c. Please note it down very carefully. This is one very beautiful rule. So logs multiplication is possible only in one case, where number in one log should be equal to the base in another log. Then only the multiplication is possible, and the number which is common is eliminated. There will be only one log in the answer with the remaining number. So the remaining number and the remaining base will come in the answer. So if I have log of 4 to the base 3 into log of 3 to the base 8, how much is it? Let's see. So here you can see this 3 and this 3 are same. So 3 and 3 gets eliminated, and the final answer will be log of 4 to the base 8. Then you can further simplify it. It is log of 2 square to the base 2 cube, which is these powers 2 and 3 will come outside. Inside we will have log 2 to the base 3, 2 to the base 2. Log 2 to the base 2 is 1. So final answer is 2 by 3. Alright. So please understand that the multiplication of logs is possible only if base in one log is same as the number in another log. Let's write down the rule here first. I'll write the rule here again. Rule is log of a to the base b into log of b to the base c is equal to log of a to. Now, if this is written here or this is written here will not matter, right? Now, from this, as you can see, if I send one of them to the other side, if I send this log b to the base c to the other side, it will be divided. So we will have log a to the base b equal to log a to the base c divided by log b to the base c, right? This is the outcome of the first rule, right? Now, how do you remember this? Let's see. If there is a log which combines a number and a base, they can be separated. How do we separate them? We introduce a third number c. Then a becomes a number in the log in numerator, b becomes a number of a log in denominator, and c becomes a base in both the places. Alright? Say for example, if there is a question like this, log 3 to the base 10. Suppose the question says log 3 to the base 10 is 0.477 and log 2 to the base 10 is 0.301. Find the value of log 3 to the base 2. How do we do it? We will follow the second rule. So here in place of a we have 3, in place of b we have 2. Alright, so log 3 to the base 2. So we introduce a third number c, and let's take c as 10, because the values of log 3 and log 2 are given in base 10. So what we write is, we take this as log 3 to the base 10 divided by log 2 to the base 10. Now these values are given, log 3 to the, we can take any base, but here we will use that base for which the values are given. Alright, so log 3 to the base 10 is 0.477, log 2 to the base 10 is 0.301, right? So you can do some approximation. Now 0.4, so decimal goes away because after decimal we have 3 digits here, 3 digits here. So we can take it as 477 upon 301. We can do approximation and make this one equal to 0. So approximate answer is 1.59. This is your final answer of this question. Let's go back here. What if I have log a to the base b into log b to the base a? What will happen here? So suppose I take b as the common number and it goes away. What are we left with? We will be left with log a to the base a. Now what is log a to the base a? Log a to the base a is 1. So that means this is equal to 1. So log a to the base b into log b to the base a is equal to 1. And from here you can see that log of a to the base b is equal to, this goes to the other side, in denominator it becomes 1 by log b to the base a. So if I have to reverse, if I have to change the position of number and base, what I need to do is take them in denominator and vice versa, right? So if there is a number log in denominator, if it comes in numerator, what will happen? The number and the base will interchange. Alright. So suppose we have log of 9 to the base 8 into log of 64 to the base 27. Now here if you notice, both 9 and 27 are powers of 3, 8 and 64 are powers of 2, or maybe 8 also. So what we can do here is, let's write this as 9 as 3 square, 8 as 2 cube into 64 as 2 to the power 6 and 27 is 3 cube. Right? Now first let's apply the first rule, that is power, rule of power. This 2 and this 3 will come outside, so it becomes 2 by 3. This power comes in numerator, this 3 comes in denominator because it is in the base. We have log 3 to the base 2 into, from here this 6 and this 3 will come outside, so 6 by 3, and we have log 2 to the base 3. Now this 2 by 3 and 6 by 3, put them together, 2 by 3 into 6 by 3 into, let's put these two logs together. So we have log 3 to the base 2 into log 2 to the base 3. As you can see, this portion will become directly equal to 1. This 3 cancels 6 2 times and we have 2 into 2, 4 by 3. So the final answer is 4 by 3. Let's take another good question. Let's take another example. Suppose we have 1 by 1 plus log a to the base bc plus 1 by 1 plus log b to the base ca plus 1 by 1 plus log c to the base ab. And the question says simplify. Now let's try and solve. See, always remember, a log and a number can never be added or subtracted. This one is a number and this is a log expression, so they can never be added or subtracted. Two logs can be added, that we have seen, but there is a condition. Condition is that base should be same. Now here it is 1, here the base is BC. So what should we do? We know that log of any number to its own base is equal to 1. So this one can be written as a log of a number to its own base. Here the base is BC. So this one can be written as, log of BC to the base BC plus, this is already log of A to the base BC. Similarly, in the next one, it is 1 divided by. This one, because of this CA, can be written as log of CA to the base CA plus log of B to the base CA. Similarly, in the third one, this one in denominator, because of this AB, can be written as log of AB to the base AB plus log of C to the base AB. Now see what happens, 1 divided by. In the first one, here it is log BC to the base BC, here it is plus log A to the base BC. BC, bases are same. So the numbers get multiplied. So it is BC into A, which becomes ABC. So we have log ABC to the base BC. Similarly, in the second one, 1 divided by. Bases are same, CA and CA. So it is log base CA and the numbers inside get multiplied. So it is CA into B, that is again ABC. In the third one, we have 1 divided by. You see, it is log AB to the base AB plus C to the base AB. So AB base same. So log of AB base, and your AB into C plus sign means numbers get multiplied. So it becomes ABC. Alright. Now we apply this rule. Log A to the base B is equal to 1 by log B to the base A. That means 1 by log B to the base A, when it goes in numerator, it becomes log A to the base B. So the number and the base get interchanged. So the first one becomes log BC to the base ABC. The second one becomes log CA to the base ABC. Plus the third one becomes log AB to the base ABC. Now you see, these are the 3 logs to be added and all of them have the same base ABC. So the numbers inside, that is BC, CA and AB, will get multiplied. So what do we get from here? We get log AB into BC into CA to the base ABC. Now what is ABC? What is AB into BC into CA? You see, it is A square, B square, C square, which can be written as log of ABC square to the base ABC. Alright. Now this 2 comes out and we have 2 times log ABC to the base ABC. Now 2 times this log ABC to the base ABC must become 1. So the final answer of the question is 2. So it's a long question, but it's an interesting one. Don't worry. It is just for the sake of practice that I have given this question. Note it down carefully. Now the last rule, rule 4. This is a very interesting rule. I'll directly give you the rule. Suppose we have a to the power log b to the base c. Please read it very carefully. The power itself is a log, right? In this, what we can do is we can interchange this a and this b without affecting the position of c. Look at the position of a. A is the base of the power here. B is the number in the log and c is the base of log. C cannot be changed. This a and b, if you interchange, it will become b to the power log a to the base c. These two are equal. This is the last rule. This is rule 4. Right? So if there is a question which says 7 to the power log of 625 to the base 49, and the question says simplify, what you can do is you can interchange this 7 and 625, so it will become 625 to the power log of 7 to the base 49. Make sure that the position of 49 is not touched, is not changed at all, is not affected at all. Now this becomes 625, and here this is 7 raised to 1 and this is 7 raised to 2. So I can write it as 7, a log of 7 to the base 7 square. So this one becomes 625 to the power. From here, this 2 comes out in denominator, so it becomes 1 by 2 log 7 to the base 7. Now, so log 7 to the base 7 has to become 1. So this becomes 1 by 2. So we have 625 to the power 1 by 2. That is square root of 625. And we all know 625 is the square of 25. So square root of 625 will be 25. So the final answer of this question is 25. So this is one very peculiar specific rule related to log. Alright. Now, please understand that any question in any exam, be it a big exam, be it a small exam, questions related to logs have to be related to one of these rules only. Alright. There is no other rule possible. Now let's take up some practice questions on the basis of the rules that we have learnt related to logs. Alright, these are very simple questions. Let's take up the first question. It says log 5 to the base 10 plus log 5x plus 1 to the base 10 is equal to log x plus 5 to the base 10 plus 1, find x. Right? This is a simple question of the basic rule that we have done, that we have learned. That is log of a to the base x plus log of b to the base x is equal to log of a into b to the base x. Right? And when it is subtraction, the number gets divided. The base has to be the same. So what we can also do is now this 1. So we know that log of any number to its own base is equal to 1. So on the left hand side, it becomes log of base is same. The numbers inside should get multiplied. So 5 into 5x plus 1. On the right hand side, we have log of x plus 5 to the base 10. And 1, we can write it as log of 10 to the base 10. So the right hand side also can be written as log of x plus 5 into 10 to the base 10. Now look at this right hand side and left hand side, base same, log same. So the number inside the log, that is 5 into 5x plus 1, this one can be equal to this number, that is x plus 5 into 10. Right? So simple calculation, 5 cancels 10 2 times, open it, we get 5x plus 1 is equal to 2x plus 10. X comes to the left hand side and we get 5x minus 2x, that is 3x. 1 goes to the other side, becomes 9. So x is equal to 3. So the final answer of this question is x equal to 3. Now let's take up the next question. Now this question says 2 divided by log 60 to the base 3, 3 divided by log 60 to the base 4, 4 divided by log 60 to the base 5, plus log 36 to the base 60, and simplify. Right? Now this is a tricky question actually. If you remember, log of a to the base b, if I send it to denominator, it becomes 1 by log of b to the base a and vice versa. So here it is 2 divided by log 60 to the base 3. So this can be written as 2 into log 3 to the base 60. Right? Similarly, the second one will be 3 into log 4 to the base 60. Plus third one will be 4 log 5 to the base 60. And the last one is log 36 to the base 60 already.
right? So one rule we have applied is this one, that from numerator to denominator when a log goes, the number and base interchange. All right. Now there is one more rule that says that if it is log of a to the power x to the base b, this power comes out. So this can be written as x log a to the base b. Now here the power is outside, right? So if the power is outside and if we send it inside, what happens? It becomes a power, right? When this x goes in, it becomes the power. Now here in this case, 2 is outside here. If it goes inside, it looks like log of 3 to the power 2 to the base 60, right? Similarly, in the second one, it becomes log of 3 goes inside and becomes power, 4 goes inside and becomes power. So log of 4 to the power 3 to the base 60 plus log of 5 to the power 4 to the base 60, and the last one is log of 36 to the base 60. Now why we are doing that? Because now we can add all these logs. So when we add the logs, the numbers inside will get multiplied if the bases are same. So here all the bases are 60. So we can say it is log to the base 60, and inside it will be 3 square into 4 cube into 5 to the power 4 into 36, right? Now what we must do is, let's see, this is equal to log of to the base 60. Now inside, if you see, this 36 is 4 into 9. I'll write it here only. It is 4 into 9. Right? Now 9 is 3 square and 4 is power 4 raised to 1. So this 9 gets to 3 square and becomes 3 raised to the power 4. This 4 goes to 4 cube and this also becomes 4 raised to 4. And this 5 is already 5 raised to 4. Now what is the benefit of this? The benefit of this will be, this becomes log to the base 60 and inside it will be 3 into 4 into 5 whole to the power 4. Now 3 into 4 into 5, 3 4 is 12, 12 5 is 60, right? So it is log of 60 to the power 4 to the base 60. So this 4 comes outside and it will be 4 log 60 to the base 60. Log 60 to the base 60 will be 1. So the answer of this question is 4, because it said just simplify. So the answer of this question is simply 4. All right. This was a little tricky question. Now let's go to the next one. Now this question says log of 9 by 16 to the base x, that is equal to minus 1 by 2. So find x, right? Now for this, the theory that we have done, that we say that log of, there is a number n to the base b, if it is equal to x, then it implies that n is equal to b to the power x, right? So these two things go hand in hand, right? So here, in place of n, we have 9 by 16. In place of b, we have x. And in place of x, we have minus 1 by 2. So what we can do is, we can say 9 by 16 from here. Directly we can say that 9 by 16 is equal to this x to the power minus 1 by 2. Right? Now, we also know that a to the power minus 1 is 1 upon a to the power 1. Or a to the power minus m is actually 1 upon a to the power m. So this x to the power minus 1 by 2 can be written as 1 by x to the power 1 by 2. Right? So this means 9 by 16 is equal to 1 by, now x raised to 1 by 2. Now anything raised to the power 1 by 2 is actually root of that number. Okay, so it is root x. Now this tells us very clearly that root x is equal to 9 by 16 is 1 by root x. So root x goes up, so it becomes 16 by 9. From here, if you simply square, right, if you simply square, you will get x equal to 16 by 9 whole square. Now 16 square is 256, 9 square is 81, right? So the final answer of this question is 256 upon 81. Alright, so this was a good question again. Now the fourth one, this again is a tricky one. It says log y to the base x, that is equal to 100, and log x to the base 2, that is equal to 10. We have to find x and y. Find x and y. We still use the same rule wherein we said that the log of n to the base b, if it is equal to x, it implies that n is equal to b to the power x. So from this one, that is log x to the base 2, this is equal to 10. From this you get x is equal to this 2 raised to the power 10. Then from this one, log y to the base x, this is equal to 100. This gives us y, if you remove log, it will give us y is equal to x to the power 100. We have already calculated x as 2 raised to 10 and whole to the power 100. So the powers get multiplied and becomes 2 raised to the power 1000. That means y is equal to 2 raised to the power 1000. Right? So this was a good question. Let's take up the next question now. Now, fifth question. It says a raised to the power x is equal to b raised to the power y. Find log a to the divide by log b. Right? Divide by log b. Now, to find this, what we need to do is, let's take a raised to x equal to b raised to y. Let's take log to the base 10. Right? See, whenever base is not given, we take the base to be 10. So take the log to the base 10. This will be log of a to the power x to the base 10 is equal to log of b to the power y to the base 10. Now what happens? We have done the rule that log of a to the power x to the base b, the power comes out. So it becomes x log of a to the base b. This is the rule. So here also the power will come out. So this x will come out. It will become x log a to the base 10. The other side will be y log b to the base 10. Right? So this means log of a to the base 10 divided by log of b to the base 10 will be simply equal to y by x. That means log a divided by log b is simply equal to y by x. Alright, so this is the answer. That's it. So nothing is mentioned. I mean the base is 10. Okay. So this question answer is simply y by x. Now, next question, it says simplify log 216 to the base 6, log 42 minus log 6 divided by log 49. These two are added. So what we have to do is, let's see, this 216 is 6 cubed. So log of 6 to the power 3 to the base 6 plus. In the denominator, it is log 49. 49 is 7 square. So we can write it as log of 7 square. Base is not mentioned, so we'll take base 10. In numerator again, log 42 minus log 6. Base is not mentioned, so we'll take the base to be 10. You can do that, right? You have to do that. So it is same base, so log of base 10. And inside it is, see, there is a minus sign in between. So numbers will get divided. We have done the rules in which say that log of x upon y to the base b will be equal to log of x to the base b minus log of y to the base b. So applying that reverse order, we can say log of 42 to the base 10 minus log 6 to the base 10 will be log to the base 10 and the number will become 42 divided by 6. Now here this 3 comes out, so we have 3 log 6 to the base 6 plus 42 by 6 is 7, so we have log 7 to the base 10 divided by, here this power 2 comes outside, so it becomes 2 log 7 to the base 10. Now here log 6 to this base 6 becomes 1, so 3 into 1. Log 7 to the base 10, log 7 to the base 10 are cancelled, so 1 by 2. So the answer is 3 1 by 2 or 3.5. Right? So this is the answer of this question. Now let's go to the next question. Now this question says find the value of x, where it is given that log of 2 plus log x to the x plus 1 to the base 2 equal to 0. Now how do we do that? First of all, whenever base is not given, we take base as 10. So here base as 10, here base as 10. Right? Here the base is already given as 2. Let me write the question again. Log of to the base 10 log 2 plus log x plus 1 to the base 2 and this whole thing to the base 10 and there is a bracket equal to 0. Now let me remove the first log first. We have already done the rule wherein we say that log of n to the base b, if it is equal to x, this means n is equal to b to the power x. Right? So applying this, if I remove the first log, this is the base and this is the value of x here. So it becomes, this 10 goes to the other side, it becomes 10 raised to the power 0. And this side we will have log of to the base 10, 2 plus log of x plus 1 to the base 2. Right? Now 10 raised to 0 is 1. Now if I have to remove the second log, now what will happen? This 10 will go to the other side and this 1 will become power. So it is 10 raised to the power 1. And this side it will be 2 plus log of x plus 1 to the base 2. Now 10 raised to 1 is 10. Now this 2 goes to the other side and we get log of x plus 1 to the base 2 is equal to 10 minus 2, that is 8. Right? Now from here, if you see, if you remove this third log, what will happen? Now the base is 2. So this x plus 1 will become 2 raised to the power 8, that is 256. So finally from here, you can see that x is equal to 256 minus 1, that is 255. Right? So the answer of this question, the value of x is 255. So this was a good, tricky question. Okay? Now let's go to the next one. Now let's take a look at this question. It says find x, right? And the equation given is 2x into b raised to the power 4 log x to the base b, that is equal to 486, right? So we have to find the value of x. Now for this question, we need to apply a rule. We have learnt it earlier. I'll write the rule here again. A to the power log b to the base c. Look at this carefully. It can be written as directly equal to b to the power log a to the base c. So what is happening? This a and this b can interchange their positions, right? This a and this b can interchange their positions. So in this case, look at the second part of this, right? So I write the equation again. This means this 2x remains as it is into, first let me put it this way, this 4 goes inside, so it becomes b to the power log x raised to 4 to the base b, right? And this whole thing is equal to 486. Now look at this. According to this formula, this b and this x raised to 4 whole thing can be interchanged. So this becomes 2x into x raised to 4 whole to the power log b to the base b, that is equal to 486. So the benefit here is log b to the base b becomes 1. So we have 2x into x raised to 4 equal to 486. Now 2 cancels 486 243 times. This we could have done earlier also. Now x into x raised to 4 becomes x raised to the power 5, that is equal to 243. Now if you factorize 243, I think you might remember that it is 3 raised to 1 is 3, 3 square is 9, 3 cube is 27, 3 raised to 4 is 81, and 3 raised to 5 is 243. So 243 is equal to 3 raised to the power 5. So this tells us very clearly that x is equal to 3, right? So the answer of this question is x equal to 3. Okay. Now let's go to the next question. Now this question says log 5 to the base 8 is given b. Find log 4 to the base 10 in terms of b. Now this is one of the best questions, right? How? Let's see. In this, what we have to do is we have to break log 4 to the base 10 and somehow we have to bring as in the form of log 5 to the base 10, log 5 to the base 8. How do we do that? Let's see. First of all, let me do one more thing. This log 5 to the base 8, which is equal to b, can also be taken as log 5 to the base 8 can be taken as 2 cube is equal to b. So this power 3 comes outside and it looks like 1 by 3. So the power from a base comes out in the denominator. So log of 5 to the base 2 is equal to b. So basically what we get here is log 5 to the base 2 is equal to 3b. Right? Let's keep this. Now, let's go to log 4 to the base 10. How do we simplify it? Log 4 to the base 10, first of all, it can be written as log of 2 square to the base 10. So this power 2 comes out, right? So it will come out to be 2 log 2 to the base 10, right? Now, let's send it in the denominator. This will become 2 divided by, so log 2 to the base 10, when it goes in denominator, it becomes log 10 to the base 2, right? Be a little careful here, log 10 to the base 2. Now 10 can be written as 5 into 2, so it is 2 divided by log to the base 2 and 10 can be written as 5 into 2. So this becomes 2 divided by log of, now when the numbers are being multiplied, logs will be added, so log 5 to the base 2 plus log 2 to the base 2. Right? So here we get our answer because we have 2 in the numerator divided by log 5 to the base 2 we have already calculated as 3b. Alright. And log 2 to the base 2 is 1. So the answer of this question is 2 divided by 3b plus 1. So this was a good tricky question. We have applied all the formula of log in this case. Alright, let's take one more question. Now in this question it says find x, and there is an expression given: log of 11 minus 6x to the base 2 is equal to 2 times log of x minus 1 to the base 2 plus 3. Right? So now what we should do is send this 2 inside the log. So this becomes, let's look at this closely, log of 11 minus 6x to the base 2 equal to log of x minus 1 whole square. When this 2 goes inside, it becomes power to the base 2 plus 3. Now let's bring this whole thing to the left hand side. So it becomes log of 11 minus 6x to the base 2 minus log of x minus 1 whole square to the base 2, that is equal to 3. Now on the left hand side, if you see, there are two logs with the same base and with a minus sign in between. So what will happen? We can say it is log of to the base 2 11 minus 6x divided by x minus 1 whole square. Right? And this whole thing is equal to 3. This means if I remove this log, what will happen? 11 minus 6x upon x minus 1 whole square will become 2 to the power 3, and that is equal to 8. Right? So now we have to solve this equation and find the answer. Right? I'll write the equation here again. It is 11 minus 6x upon x minus 1 whole square equal to 8. Right? Now simplify this. So from here we see that 11 minus 6x divided by x minus 1 whole square is x square minus 2x plus 1, that is equal to 8. Cross multiply, it will give us 11 minus 6x equal to 8 into x square minus 2x plus 1. Open it, it will be 11 minus 6x is equal to 8x square minus 16x plus 8. Let's bring all of them on the other side. So 0 is equal to 8x square minus 16x plus 8 minus 11 plus 6x. So finally we have 8x square minus 16x plus 6x, that is minus 10x, and plus 8 minus 11, that is minus 3, that is equal to 0. Right? So it is 8x square minus 10x minus 3. Now 8 into 3 is 24 and 4 into 6 is 10, but here is a minus sign. So 12 into 2 is 10, correct. So this can be taken as 8x square minus 12x plus 2x minus 3 equal to 0. So this gives us, if I take 4x common, this gives us 2x minus 3 plus 1 common, 2x minus 3. So finally we have 2x minus 3 common from everything into 4x plus 1, that is equal to 0. So this tells us that from this one x is equal to 3 by 2, and from the other one x is equal to minus 1 by 4. Right? Now let's just see whether it can be, whether x can be negative or not. If you look at the expressions, x cannot be negative, right? Why? Because it is x minus 1 originally in the log. So if x is negative, x minus 1 will become further negative, and a log cannot have a negative number, right? So this means we can discard x equal to minus 1 by 4. Okay, so this is not the appropriate answer. So the correct answer is x equal to 3 by 2, right? So this is the answer of this question. Okay, now let's go to the next part.
Now let's take, there is one application of logs, that is to find the number of digits in a very big number. Say for example, if the question says find number of digits in 2 raised to the power 53. Alright, now how do we solve this? To understand this, first let's look at some simple numbers. How many digits are there in 10 raised to the power 3? We already know that 10 raised to the power 3 is 1000. So the number of digits is 4. Now how does this help? I'll tell you. To find the number of digits, now whenever we write a number, we follow the decimal system. Now decimal system means base 10. Alright. So to find the number of digits, we will be using log. Log to the base 10. And how do we do that? Let's see. I'll give you an analogy here. Find log of 10 raised to the power 3 to the base 10. It is equal to 3 log 10 to the base 10. Now log 10 to the base 10 is 1. So final answer is 3. So if you know the log of a number to the base 10, the number of digits is equal to whatever log you have calculated to the base 10 plus 1. always, right? So first write the theoretical aspect of this situation. Suppose if there is a number n and you have to find the number of digits in n. So number of digits in n is equal to the integer part of log n to the base 10 plus 1. Integer part of log n to the base 10 plus 1. Now what does it mean? Come back to this question. If I say that find number of digits in 2 raised to 53, then here there must be an information given that log 2 to the base 10 is 0.301. This is given, and don't worry, it will be given in the questions. Just remember this rule. Suppose there is a number n which is 2 raised to the power 53. To find the number of digits, what is the procedure? First you find log n to the base 10. So here log n to the base 10 is log 2 raised to the power 53 to the base 10. Right? Now the power will come out. So we'll have 53 into log 2 to the base 10. Log 2 to the base 10 is given 0.301. So we will have 53 into 0.301. Multiply in a simple manner. We will have 53, 3 is 159. So it is 15953. There are 3 digits after decimal, so it is 15.953. Now look at the integer part. The integer part is 15. Do not worry about the decimal part at all. Ignore them. For 10 raised to 3, we already had only an integer number, right? For 2 raised to 53, we have 15 before decimal, that is the integer part of the number. 0.953, that is the decimal part of the number. Ignore it completely. Take only the integer part, that is 15. Now that also means if you have made any mistake here in calculation of this, you see this is 15.953, which is very close to 16. So if you make a mistake, it may go up 16, above 16, then you will have to consider 16, which will be wrong. So make sure that you have multiplied correctly. So it is 15.953. So number of digits in 2 raised to 53 is equal to this 15, that is the integer part of the log, plus 1, that is 16. So just remember that this is one complete thing and plus 1. Okay. Now let's take another example. Suppose I say that find number of digits in 5 raised to the power 53. So the first step is find log of 5 raised to the power 53 to the base 10. This 53 is the power, so it will come out. So we will have 53 log 5 to the base 10. Now this 5 can be written as 10 by 2. So we will have 53 log 10 by 2 to the base 10. Now, because it is a division, we can separate them. So 53 is completely outside, and inside we will have log 10 to the base 10 minus log 2 to the base 10. I hope you remember the rules 2, second rule. So x by y, that means log x minus log y, base should be same. Now see, this is 53 into log 10 to the base 10 is 1 minus log 2 to the base 10 is 0.301. So in the beginning you must be thinking that log 5 is required. You can actually calculate log 5 if log 2 is given. Alright. Now, so one way is you can subtract this and then multiply 53, or you can open here itself. So 53 into 1 minus 53 into 0.301. So the calculation becomes a little easier. Now this is 53 minus 53 into 0.301 is 15.953. Subtract it very carefully. It is 37.047. Again, you can't afford any mistake in this calculation, right? Now integer part is 37. So the number of digits in 5 raised to 53 is equal to 37 plus 1, which is 38. So the final answer of the question will be 38. So there are 38 digits in this number 5 raised to 53. Number of digits in n is equal to integer or before decimal part of log n to the base 10 plus 1. Alright, this is what it is. Right? Now, do not worry, you will not be required to memorize the values of log. If there is any log value required, it will be given in the question. Okay? Let's take another example. Find number of digits in 2304 to the power 100. Now for this, log 2 to the base 10 is given 0.301. Log 3 to the base 10 will be required is given 0.477. Now let's calculate this. First we need to take log of 2304 to the power 100 to the base 10. Remember, you have to take log value to the base 10. So this will become, this 100 is a power, so it will come outside straight away. Inside we have log 2304 to the base 10. Then you have to factorize 2304. Now 2304, if you remember the squares, it is 48 square. If you don't, divide it. So 2304 factorized form is 2 raised to the power 8 into 3 raised to the power 2. Put it here. So it is 100 times log 2 raised to the power 8 into 3 square to the base 10. Alright. Now, in the log, when you have multiplication, the numbers get added, or logs get added. So we have 100 times log 2 to the power 8 to the base 10 plus log 3 to the power 2 to the base 10. Then we have 100 times, be very careful in calculation here. Now in this one, 2 raised to 8, this 8 comes out. So we have 8 times log 2 to the base 10. And in this 3 square, 2 comes out. So we have 2 times log 3 to the base 10. Now put the values of log 2 to the base 10 and log 3 to the base 10. So it becomes 100 times 8 into 0.301 plus 2 times 0.477. If you multiply and add, it is 100 into. Now 8 times 0.301, simple multiplication is 2408. So it is 2.408 plus 2 times 0.477, so it is 2346. So it is 0.954. Simple multiplication, you have to obviously use the table of 2 here, table of 8 here. Now if you add them, it will be 100 into, on addition it gives us, so it is 100 into 3.362, so it is 336.2, right? Look at the integer part, that is 336. So number of digits in the given number of digits in 2304 to the power 100 is equal to 336 plus 1. So the final answer will be 337. So this is how we can find the number of digits in any big number, right? Remember, whatever log value will be required, it will be given in the question. You don't have to memorize the value of log. Okay. Now one more topic in logs. The question is asked like this, that how many zeros are there after decimal before first non-zero digit in a number. Let's take an example. Let's say we have 2 by 3 raised to the power 400. Alright, so what we do in this? So first I'll give you the theoretical aspect. Just make sure that the log is calculated correctly and you take the integer part of that number. Just the integer part. Alright. So for example, if I say that log of n to the base 10 is minus 5.48. Alright. Then the number of zeros after decimal before first non-zero digit is straight away equal to 5. Remember? See, when we did number of digits, what we said was it is the integer part plus 1. Here we are only talking about number of zeros after decimal before the first non-zero digit. It is simply the integer part of this log. Forget the negative sign, forget the decimal part, just the integer part. That is the number of zeros after decimal. Alright. So fundamentally, we still have to calculate the log. So for example, for this number, if I calculate log of 2 by 3 to the power 400 to the base 10, this will be equal to, the power comes outside, so 400, and then log 2 by 3 to the base 10. Now what will happen here? So we will get 400. Now because it is division, it will separate like this, log 2 to the base 10 minus log 3 to the base 10. And remember, log 3 and log 2 would be given, so nothing to worry about. I'll write again here, log 2 to the base 10 is 0.301, and by now you would remember this. Log 3 to the base 10 is 0.477. Put them here, you will get 400 into log 2 to the base 10 is 0.301 minus log 3 to the base 10 is 0.477. If you subtract, you get 400 into minus, so it is 0.176. So if you multiply by 400, it will become minus 70.4, right? This directly gives us the answer of our question, and that is 70. So 70 is the answer of this question. So we can say that there are 70 zeros after decimal before first non-zero digit in 2 by 3 raised to the power 400. So the answer is 70 zeros. Alright, let's take one more example just to understand that in a better manner. What you have to remember is that any number which is less than 1, which is a fraction, the log of that number will be negative. In that log, just look at the integer part of that log value, right? That will straight away give you the number of zeros after decimal before the first non-zero digit. Suppose it is, let's say 5 by 6 to the power 24. Alright, so what we do is we take log of 5 by 6 to the power 24 to the base 10. So it is 24 times log 5 by 6 to the base 10. It is 24 times log 5 to the base 10 minus log 6 to the base 10. Now 24 times 5 can be written as 10 by 2 to the base 10 minus log 6 can be written as 2 into 3 to the base 10. Now if you open it, it will become 24. 10 by 2 is log 10 to the base 10 minus log 2 to the base 10 minus. Now this will become log 2 to the base 10 plus log 3 to the base 10. So here it will come log 2 to the base 10 minus log 3 to the base 10. Put the values carefully. So it is 24 into log 10 to the base 10 is 1 minus. This is 0.301. This is also 0.301, so multiplied by 2 minus log 3 to the base 10 is 0.477. So this comes out to be 24 into 1 minus, this is 0.602 minus 0.477. So this is equal to 24 into, if you add and subtract, these two together will become, so 1 minus 1.079. So it is 24 into minus 0.079. Alright, so multiplied by 24. So it is minus 1.896. So look at, here the integer part is only 1. So that means 5 by 6 raised to 24, the number of zeros before first non-zero digit after decimal is just 1, right? Is just 1. That is the answer of that question. Alright, so here we have completed all the topics of log.
Now we will take a couple of more questions on finding the number of digits, okay, in a large number. Let's take the first one. So the first number is 24 raised to the power 120, right? So here our number is equal to 24 to the power 120. First, let's factorize it, right? Because to find the number of digits, this is the rule written here. It says the number of digits in a number n is equal to integer part of log n to the base 10. That means the first what we have to do is we have to find the value of log of the number n to the base 10. Whatever is integer part of that number plus 1 will be the number of digits. Alright, so here our number n in the first question is 24 raised to the power 120. Now let's factorize it first. 24 is equal to 8 into 3. 8 can be written as 2 cube into 3 whole to the power 120. Now let's take log n to the base 10. So this will be equal to log of 2 to the power 3 into 3 whole to the power 120 to the base 10. Now we have done the rules of log, that log of a to the power x to the base b is equal to, this power x comes out, so it becomes x log a to the base b. So here the power is 120, the whole thing will come out. So we will have 120 log 2 cube into 3 to the base 10. Now we also have done a rule in which log x into y to the base b is equal to log x to the base b plus log y to the base b. Okay, so what we can do here, now this is 2 cube into 3, so we can take it as 120 will remain outside, so it is 120 into log of 2 cube to the base 10 plus log of 3 to the base 10. Now finally it is 120 into, now log 2 cube, here again 3 is the power, so 3 will come out, so we will have 3 log 2 to the base 10 plus log 3 to the base 10. Now in the question it was already given, the log 2 value is given 0.301, log 3 to the base 10 is 0.477, and log 7 is also given. Now in this one, log 2 and log 3 will be utilized. Alright, so what we can do is, we can put the values of logs here and we can calculate log of n to the base 10 as equal to 120 into 3 into log 2 to the base 10 is 0.301 plus log 3 to the base 10 is 0.477, right? So this is 120 into 3 into 0.301 is equal to 0.903 plus 0.477, right? So if you add, it will become equal to 120 into 1.380. And then when you multiply this by 120, it will become equal to 165.6, right? Okay, so finally, what do we have? We have log of n to the base 10, the number n that we had 24 raised to the power 120. For that, we have log of n to the base 10 is equal to 165.6, right? Now, what is the integer part of this? The integer part of this is 165. That means the number of digits, the total number of digits in the given number n, which was 24 raised to the power 120, is equal to the integer part of log, that is 165, plus 1, that is 166. So answer of this question is 166 digits in the number 24 raised to 120. Alright, now let's go to the next question. Now our second number is 70 raised to the power 30. Right, so let's say this is n equal to 70 raised to the power 30. So let's straight away try to find the log of this value. So log of n to the base 10, this will be equal to log of 70 to the power 30 to the base 10. As we have just done the rule, log of a to the power x to the base b is equal to x log a to the base b. Here also the power 30 will come out, so it will be 30 log 70 to the base 10. Now 70 is actually 7 into 10, so it is 30 into log of 7 into 10 to the base 10, right? And we also have done the rule, that is log of x into y to the base b is equal to log of x to the base b plus log of y to the base b, right? So this is equal to 30 into log 7 to the base 10 plus log 10 to the base 10. Right? Now here log 7 to the base 10 is given 0.845. So it is 30 into 0.845 plus, now log 10 to the base 10, that is equal to 1. Log of any number to its own base is 1. So finally what we have is log n to the base 10 in this case is equal to 30 into 1.845. So if you multiply, you will get 55.35, right? So we have log of the given number to the base 10, that is equal to 55.35. Okay, that means the number of digits in this number, following that rule in the number n is equal to, the integer part of log is 55. So we have done the rule, that is integer part of the number, log of the number to the base 10 plus 1. So it is 55 plus 1, that is equal to 56. right? So just find the log of the number to the base 10, take the integer part, add 1. That will give you the number of digits. So answer of the second one is 56. All right. Now let's take one more question on the basis of this. Now this third number is 2304 raised to the power 50. So let's say our n, the number n is equal to 2304 to the power 50. So the first step to find the number of digits is take log of n to the base 10. So here it will be log of 2304 to the power 50 to the base 10. So first of all, following this first rule, the power will come out. So 50 will come out. So it will be 50 into log of 2304 to the base 10. Now you have to factorize 2304. Now there are many ways to factorize, right? If you remember, it is square of 48. It will be really easy. Otherwise, you can factorize like this. Let's say 2304. First step, I think it is visibly divisible by 4. So divide by 4. If you divide by 4, it will give you 4 5s are 20. So 5, 4 7s are, and then 4 6 are 24. Now 576 24 square, right? So at least you must remember 24 square is 576, so that it becomes simply 24 into 24. If you don't remember, again go ahead, divide by 4. So 4 1s are 17, 4 4s are, and 4 4s are. Now 144 is 12 square. So what we have here is 4 into 4 into 144. So let me say 2304 is equal to 4 square into 144 is 12 square, right? So it is 4 into 12, that is 48 square. Okay, so at least we can do it again like this. Log of n to the base 10 is equal to 50 into log of 48 square to the base 10. Now from here 2, this 2 again will come out. So it will be 50 into 2 log 48 to the base 10. Alright. So now this is equal to, now 50 into 2 is 100. Now log, now 48 is 16 into 3. Right, 48 is equal to 16 into 3, and 16 can be written as 2 raised to the power 4 into 3. So I will take, in place of 48, we will take 2 raised to the power 4 into 3 to the base 10. Now following this second rule, this rule, the product rule, log x into y to the base b, log x to the base b plus log y to the base b, this thing 2 raised to the power 4 into 3, this log can be taken as 100 into log of 2 raised to the power 4 to the base 10 plus log of 3 to the base 10, right? So what we have is, it is 100 into, it will become, this 4 again will come out. So it is 4 log 2 to the base 10 plus log 3 to the base 10, right? Now the values of log 2 and log 3 were given in the question. Log 2 was given as, log 2 to the base 10 was given as 0.301. And log 3 to the base 10 is given as 0.477. Put these values here. So this becomes 100 into 4 into 0.301 plus 0.477. Okay. So this comes out to be 100 into 4 into 0.301 will be 1.204 plus 0.477. Now if you add them, it will become 100 into 1.681. So this is 168.1, right? So that means the log value, log of n to the base 10, that is equal to 168.1. All right. So the number of digits in that number n, which was 2304 to the power 50, is equal to the integer part, that is 168, plus 1, which is equal to 169. So the answer of this question is, there are 169 digits in that number. Alright. So here we have completed the process of finding the number of digits. Now let's go on to the next part, in which we have to find the number of zeros after decimal before the first non-zero digit in a very small number. Right. So this was a very large number. Right. So here we were talking about finding the number of digits in a large number. Okay. Now we will look at finding the number of zeros after decimal in a very, very small number. All right. Now let's take up this segment. We are saying that we have to find the number of zeros after decimal before the first non-zero digit in the very small fraction. So here the question is, find the number of zeros after decimal before the first non-zero digit in the following numbers or fractions. Some log values are given. Alright, so log 2 is given 0.301, log 3 to the base 10 is 0.477, log 7 to the base 10 is 0.845. Right? So the first question is find the number of zeros after decimal before the first non-zero digit in 4 by 5 raised to the power 300. First, I've written the rule here. It says the first point is for a fraction which is less than 1, the log value is always negative, right? And the number of zeros after decimal before the first non-zero digit in that fraction f is the fraction that I'm assuming, is simply equal to the integer part of that log value of f. So one point is that log value will always be negative. Whatever log value comes, only the integer part of that number will be the number of zeros. Alright. So let's take our first fraction here. Let's say it is f, right? So f is 4 by 5 to the power 300. Okay, so f is equal to 4 by 5 to the power 300. So what is the working rule? The rule is you take log of f to the base 10, right? And you calculate it. So it is log of, this was 300. So it is log of 4 by 5 to the power 300 to the base 10. Now for convenience, I'll write 4 by 5 as 8 by 10. So it is log of 8 by 10, right, to the power 300 to the base 10. Alright. So now we have two rules here. One rule is log of a to the power x to the base b. The power x comes out. So it is log of a to the base b. So from there we will have log of f to the base 10 will be equal to, this power 300 will come out, and inside we will have log of 8 by 10 to the base 10. And the other rule is log of x divided by y to the base b is equal to log x to the base b minus log y to the base b. So applying this, we can take this as 300 into log 8 to the base 10 minus log 10 to the base 10. Right? So we will say log f to the base 10 will be equal to 300 into. Now 8 is 2 cubed, so it is log of 2 to the power 3 to the base 10 minus log 10 to the base 10 is 1. So it is equal to 300 into. Now from here 2 cube, this power 3 will come out. This power 3 will come out here. So it is 3 log 2 to the base 10 minus 1. Okay. So what we have here is log f to the base 10 is equal to 300 into this 3 into log 2 to the base 10 is 0.301. So put it here minus 1. So it is 300 into 3 into 0.301 is 0.903 minus 1. So this is equal to 300 into, now look at this carefully, this 0.903 minus 1, this will be negative, right? And it will be minus 0.097. All right. So what we have here now is that log of f to the base 10 is equal to minus 300 into 0.097. So if you multiply, it will come out to be minus 29.1. Right? Now what did we say? We said that the number of zeros after decimal before the first non-zero digit, right, is equal to only the integer part of the log value. See, log will come negative, that we have already said. And we have to take only the integer part. So here the integer part is 29. So answer of this question is straight away 29. Right? So if I calculate the actual value of f, in this case it was 4 by 5 to the power 300, we will get a very large number, in presentation, like 0 point something, right? And then there will be a first non-zero digit will appear, let's say k, and so on. So from after decimal to k, the number of zeros in this space is 29. That is what the question means to say, right? So, but we don't have to get into details of this. We just have to calculate the log value of that number, and we take the integer part of that log value. That will be our answer. All right. So answer of first question is 29 zeros. Okay. Now let's take the next one. Now the second one, it is 1 by 3 raised to the power 500, and we have to find the same thing, number of zeros after decimal before the first non-zero digit. Alright, we still have the log 2, log 3, log 7 values, and still the same rule follows. What we have to do is find the log value and just take the integer part of that log value. Okay, so let's say this is our number f. So what we have to do is log of f to the base 10 will be equal to log of 1 by 3 raised to the power 500 to the base 10. Now this power 500 will come out as we have done the rules earlier. So we have this rule, log of a to the power x to the base b is equal to x log a to the base b. So here the power 500 will come out and we will have log f to the base 10 is equal to 500 into log 1 by 3 to the base 10. Now 1 by 3 can be written as 3 raised to the power minus 1, alright, to the base 10. Again this power minus 1 will come out and we will have 500 into minus 1 into log 3 to the base 10. Now log 3 to the base 10 is given here, that is 0.4771, alright, so we'll use it now. We put the value here, we'll get minus 500 into 0.477. So finally, if you multiply, you will get minus 5. 2 zeros will replace or will shift the decimal. It will be 47.7. So if you multiply, it comes out to be minus 238.5. So log of that fraction or that number f to the base 10, we have calculated minus 238.5. Right? So integer part is 238. So straight away the number of zeros after decimal before first non-zero digit in this number, given number, let's say in that number 1 by 3 raised to the power 500 is straight away equal to 238. So whatever the integer part we get, that is the answer. Alright. Let's go ahead and take one more question in this. Now the last one, it says the number of zeros after decimal in this number 3 by 7 raised to the power 200. Let's say this is number f. So we have to find a log of f to the base 10, that will be equal to log of 3 by 7 to the power 200 to the base 10. Right? So as we have done the rules earlier, this from this rule the power 200 will come outside. So we will have log of f to the base 10 is equal to 200 into log of 3 by 7 to the base 10. Right? Now here we also have the other rule as log x by y to the base b is equal to log x to the base b minus log y to the base b. Using that, we can say this one is equal to 200 into log 3 to the base 10 minus log 7 to the base 10. Right? So we already have the values of log 3.477 and log 7 is 0.845. So put it here. So we will get 200 into log 3 to the base 10 is 0.477 minus log 7 to the base 10 will be 0.845. So by simple subtraction, we are going to get 200 into, now 0.477 minus 0.845 will be minus 0.368, right? So if you carefully multiply it as minus of 2 zeros will shift the decimal to 2 places to the right. So it is 2 into 36.8, which comes out to be finally minus of 73.6, right? So this means that log of that number, log of f to the base 10, that is equal to minus 73.6. So as you can see, the integer part of this number is just 73. You don't have to bother about minus sign because it's a fraction, so log will definitely be minus, right? The answer of that question, which says the number of zeros, right, after decimal before the first non-zero digit in the number 3 by 7 raised to power 200 is equal to this integer part, that is 73, right? So this is the answer of this question. So I think now we have completed all aspects, all formulae and different types of questions, and a lot of practice we have already done as far as logs are concerned. We have also taken a lot of you can say the questions on the basis of log. We have also taken different types of applications in finding the number of digits, in finding the number of zeros after decimal, and so on. Alright, so I would just suggest that you repeat the video, and still if you have any doubt, you can always come back to us. Alright, thank you so much. God bless you. Take care.